Hi there, in this video I'm going to prove some integration results using hyperbolic substitution. So the first result, I'll call this result number 1. So let's take both pen and underline this. Result number 1 is when we integrate 1 over the square root of x squared plus a squared with respect to x, that should give hyperbolic sine inverse x over a plus c. Okay, so that is the first result that we're going to prove. So I'm going to prove this using substitution, and this is how the proof is going to be done. So in this case we prove, as I said, using substitution, and we need to use substitution x equals a hyperbolic sine theta. Okay, so since we're using substitution, so let's call this step number 1, the substitution that we're using. Step number 2 is to calculate dx by d theta, so we differentiate. So remember, when you differentiate hyperbolic sine, you're going to get hyperbolic cos, so you'll get a hyperbolic cos theta. Okay, and dx as a result is a hyperbolic cos theta d theta. Okay, so I'm going to use substitution on the left hand side of this integral, so that's the idea, using the substitution on the left hand side, and we're going to replace dx by a hyperbolic cos theta d theta and we're going to replace the x here by a hyperbolic sine theta. So by substitution, so let's go through the process and let's call this step 3. So integration sine dx here is a hyperbolic cos theta d theta, so we'll replace that by a hyperbolic cos theta d theta, so that's dx replaced, over, so over the square root of x is replaced by a hyperbolic sine, so we'll have a hyperbolic sine theta, don't forget to square, plus a squared. Okay, so our x is replaced by a hyperbolic sine theta, dx replaced by all of this, a hyperbolic cos theta d theta. Okay, so if we continue, we're going to have a hyperbolic cos theta, okay, over the root of, so in this case I'm going to have an a squared when I expand the bracket here, so I'll have an a squared hyperbolic sine squared theta, okay, plus a squared, so we're going to have a squared hyperbolic sine squared theta plus a squared under the square root. Okay, now in my next step what I'm going to do is, so I have a hyperbolic cos theta in the numerator, and what I'm going to do is I'm going to take out a common factor, so I'll take out a common factor of a squared out of the root. So if I take out a common factor of a squared out of the square root of a squared is a, and I'm left with the root of hyperbolic sine squared theta plus 1. Okay, so I hope you can see that. Yeah. So I've taken out a common factor of a squared out of the root, leaving me with the root of hyperbolic sine squared theta plus 1. So as a result, these two a's will cancel, and that takes us, so I'll call this step number 4, so it takes us to step number 4. Now, whenever, this is how I think about it, whenever I use a trigonometric, or in this case a hyperbolic substitution as well, okay, 10 times out of 10 you'll be using a hyperbolic identity, okay, particularly in order to simplify your integral. So I'm going to be using a hyperbolic identity to simplify or to replace, okay, the root term here, and the identity that I'm going to be using is hyperbolic cos squared theta minus hyperbolic sine squared theta is equal to 1. The reason being is if I rearrange this for hyperbolic cos theta is precisely the root of hyperbolic sine squared theta plus 1. So it's precisely this term, this root term, when we rearrange. Okay, so as I said before, 10 times out of 10 you'll be using an identity to simplify your integral. Okay, and we also do this if we're integrating using a trigonometric substitution. Okay, so if I do the replacement here, I'm going to have the integration of hyperbolic cos theta on top. This root term can be replaced by a hyperbolic cos theta below with respect to theta. Okay, so as a result, these two terms will cancel, giving us 1 to integrate, and when you integrate 1, of course, you'll get theta plus c. Okay, so now remember, we need to write this theta in terms of x, and we write theta in terms of x using the substitution. So that takes us to the last step. So let me continue over here. So this is step number, so let's remind ourselves that was step number 4, the application of the identity, and the last step is step 5. So since x equals a hyperbolic sine theta, when I rearrange, theta will be the inverse hyperbolic sine of x over a. Okay, and finally, if you replace the theta here by the inverse sine of x over a, you've got your result. So therefore, it's indeed the inverse hyperbolic sine x over a plus c. Okay, so that concludes the proof. So I've explained the proof of this result, and I've broke down the proof into steps. So I hope you found these steps helpful. So I did the best that I can in order to break it down so that it's understandable for you. So I'll call this result number 2. You underline that, and we're going to prove that whenever we integrate 1 over the square root of x squared minus a squared with respect to x, we're going to get hyperbolic cos inverse x over a plus c. Okay, so here's the method. So in the previous result, to prove the inverse hyperbolic sine, we use the substitution x equals a hyperbolic sine theta, and we use this substitution to prove the inverse hyperbolic sine relation. So in this particular case, we're going to use the substitution x is equal to a hyperbolic cos theta to prove the inverse hyperbolic cos relation. Okay, so in step number 2, let me differentiate dx by d theta. So standard result when you differentiate hyperbolic cos theta, you're going to get hyperbolic sine theta. So it will be a hyperbolic sine theta in this case. Okay, and dx will be a hyperbolic sine theta d theta. Okay, so these are the steps that I exactly did with the previous result. So we're up to here if you want to compare. Okay, step number 3 is using the method of substitution. So replace the existing variables by the new variables theta and d theta. So let's have a look over here. So in step number 3, by substitution. Okay, so I hope you can see that. So the dx over here we're going to replace by a hyperbolic sine theta d theta. So a hyperbolic sine theta d theta divided by the square roots, so divided by the square roots of x squared. So x is a hyperbolic cos theta, so we'll have an a hyperbolic cos theta squared, so don't forget the squared, minus a squared, so minus a squared. And if we expand the term within the root, we're going to have a hyperbolic sine theta on top over the square root. A hyperbolic cos theta squared is a squared hyperbolic cos squared theta minus a squared. Okay. Now, in the previous video, what I've done was I've taken a common factor of a squared out of the root. Okay, so it's no different here. I'm going to take out a common factor of a squared out of the square root. So by doing so, square root of a squared is a, and that will cancel with the a with the numerator. Okay, so let's have a look. So I have a hyperbolic sine theta on top over a into the root of hyperbolic cos squared theta minus 1. These two a's will cancel. Okay, and in the previous video I mentioned that if you're using a hyperbolic substitution, 10 times out of 10 you'll be using a hyperbolic identity to simplify your integral. Okay, in particular to replace this root term by something else. Okay, so in this case I'll call this step number 4. So by using, and the identity that we're going to be using is hyperbolic cos squared minus hyperbolic sine squared theta is equal to 1, because the reason being is when you rearrange this identity you're going to get this term precisely. Okay, so if I rearrange here, hyperbolic sine theta when rearranged will indeed be the root of hyperbolic cos squared theta minus 1. Okay, so let's do the replacement. Let's replace this root term by hyperbolic sine theta. So let me continue on the reverse. So we're going to have the integration of, so let's remind ourselves. So I've got a hyperbolic sine theta on top, so hyperbolic sine theta on top divided by, and the root of hyperbolic cos squared theta minus 1 is hyperbolic sine theta. So divided by hyperbolic sine theta. Okay, so as a result the two terms will cancel, giving us 1, and when you integrate 1 you're going to have theta plus c. Okay, so we need to write theta back in terms of x, and if we go back we do that using our substitution. So that comes to step 5 of the method, so that brings us to step 5. So in step number 5, since x equals a hyperbolic cos theta, okay, so a hyperbolic cos theta is x, cos theta is x over a, so hyperbolic cos rather is x over a when rearranged, and theta is the inverse hyperbolic cos of x over a. Okay, so if I replace theta by the inverse hyperbolic cos of x over a, we have our result, the inverse hyperbolic cos x over a plus c. Okay, so that concludes the proof of that result. Let's call this result number 3. So the result is whenever you integrate 1 over a is a constant, so a squared minus x squared with respect to x, the result is 1 over a hyperbolic tan inverse x over a add c. Okay, so to prove this result, we're going to use hyperbolic substitution. Okay, in the previous result, that we've seen in the previous video, we had a result involving hyperbolic cos inverse, and that substitution that we used was x equals a hyperbolic cos theta. In this result, we're going to be using the substitution, and you might have guessed it, x equals a hyperbolic tan theta. Okay, so step number 2, when I differentiate, dx over d theta will be a hyperbolic sec squared theta. Okay, and dx will be a hyperbolic sec squared theta d theta. Okay, so we're going to replace the dx as a result by a hyperbolic sec squared theta d theta, and we're going to replace the x over here by a hyperbolic tan theta. So that takes us to step number 3. So if you've seen the proof that that was explained in the previous video, so if I take that proof, we're up to here so far, so this is step number 2. Step number 3, we go through the method of substitution. So let's go through the method of substitution over here. So in this case, the dx is going to be replaced by a hyperbolic sec squared theta d theta. X is going to be replaced by a hyperbolic tan theta. So by substitution, so I hope you can see that. So dx is replaced by a hyperbolic, hyperbolic sec squared theta d theta over an a squared minus, and x is replaced by a hyperbolic tan theta. So I've got an a hyperbolic tan theta squared. Okay, so don't forget the squared. Now let me expand the brackets in the denominator. So I have a hyperbolic sec squared theta on top over, and if I expand this bracket in particular, I'll have a squared minus an a squared hyperbolic tan squared theta below. Okay, so in order to simplify, I'm going to take out a common factor of a squared in the denominator. So I have a hyperbolic sec squared theta on top, taking out a common factor of a squared below will leave me with 1 minus hyperbolic tan squared theta. Okay, and that takes us to step number 4. Okay, so if you've seen the previous video and the video prior to that, remember what I said. I said if you're using a hyperbolic substitution, 10 times out of 10 you're going to be using a hyperbolic identity to simplify your integral. Okay, now there is an identity that is exactly this, 1 minus hyperbolic tan squared theta, and the identity is, so we're going to be using in this instant 1 minus hyperbolic tan squared theta, that is equivalent to hyperbolic sec squared theta. Okay, so if I replace the 1 minus hyperbolic tan squared theta by hyperbolic sec squared theta, we're going to have, so a hyperbolic sec squared theta over, okay, we have an a squared here, 1 minus hyperbolic tan squared is hyperbolic sec squared, theta below. As a result, the two hyperbolic sec squared terms will cancel, but also one of these a's on the top will cancel with only one below. Okay, so be careful with your cancellation. You should be left with a 1 over a to integrate. When you integrate 1 over a with respect to theta, it's 1 over a with a theta plus c. Okay, so that takes us to the last step. We need to write theta back in terms of x, and we do that using our substitution. Okay, so let's rearrange. So let's continue on the reverse. So the last step, step number 5. So since x equals a hyperbolic tan theta, if we rearrange, a hyperbolic tan theta is equal to x, hyperbolic tan theta is x over a, and theta on its own is the inverse hyperbolic tan of x over a. Okay, so if we go to the previous step, we can replace theta over here by the inverse hyperbolic tan x over a in order to conclude the proof. So we're going to get, as a result, 1 over a inverse hyperbolic tan x over a plus c, and that completes the proof. Okay, so that ends this video. I hope you found this video helpful, and I hope to see you in the next video. Thank you.